In level 4, we're going to use the graphing calculator to find some information about a parabola. So the first thing you're going to do is press the y equals button. If you see my little hand, it's on the bottom left, right under the screen. So go ahead and press y equals. And you're going to enter the equation up above. So this equation up here at the top, use x's instead of t's. And you will find the x button right next to alpha. So I'm pointing at it with my little pointer. It says xt theta n. That will give you the x. Also, when you plug in the negative sign, make sure you use this negative button instead of the minus. This minus is for subtraction. This minus is for negative. So use the negative symbol down at the bottom, and then x, and then squared is the x squared button on the left, and then plus 5x plus 9 until your calculator looks just like mine. Also make sure that these plots where it says plot 1, plot 2, plot 3, those should not be highlighted. If they are highlighted, go up to the top and press enter on them so that they are not highlighted. They should be just clear like that. Next, you're going to hit graph. The graph button is on the right side, right under the screen on the far right. It says graph. Press that button, and your your screen might look like this screen right here. If it doesn't look exactly like mine, you can press the zoom button, which is under the screen in the middle, and then if you press number 6 for zoom standard, it gives you the standard window, which is shown in my picture, and that just means that the x-axis goes from -10 to 10, and the y-axis goes from -10 to 10. And that's always a good place to start. It's not actually what we want because we need to zoom in a little bit and go up higher. If you think about this problem, it's about time, or the height of an object as time passes, and time can never be negative. So we don't need the left side of this graph where the x values or t values are negative. So we really want our x's to go, our x min to be 0, and our x max, 10 seems to be working fine because we can see where it touches the x-axis. So from 0 to 10 I think is a good choice. And then for our y values, the height of the ball, assuming it's not going below sea level, is not going to be negative. But sometimes it's nice to be able to see the x-axis, so you can make your y min like -5 or something, just so we have a little bit of space where we see the x-axis, but then we need to go up quite a bit higher. So our y max, and this we sort of guess on how high we want it to be. We might want it to go up to, say, 20, and maybe that'd be high enough where we could see the top of this graph or the vertex of the parabola. So I'm going to guess 20. Now if you press the window button, and the window button is next to y equals, you should see this screen, and it will say -10 for x min, 10 for x max, and -10 to 10 for y min and y max as well. So you can change those. We're only going to be dealing with x min, x max, y min, y max. That's all you need to worry about. And I changed mine to be 0 to 10 and -5 to 20. And then if you press graph, you will go back to your graph. And your graph should look like this now that we've changed the window. So we have our x-axis going from 0 to 10, our y-axis going from -5 to 20, and we can see the top of the parabola, so that was a good choice for the window. Now we're ready to answer some of the questions. So the first part, part A, asks for the time it takes for the ball to reach its maximum height. And the maximum height is going to occur at the very top of the parabola, or we're finding the vertex or the maximum point of the parabola. And to do this, you're going to press the buttons second and then trace. And that will get you to this screen right here. And so again, the buttons are second, the blue button, and then trace, which is next to graph on one of those 5 buttons below the screen. And there's a couple options. We're going to use that screen for a couple different things. The first thing we're going to be finding is the maximum point. So you're going to choose number 4. And when you do that, it's going to say left bound question mark. So when it says left bound question mark, you'll see a little spider, this little spider thing, and if you move your buttons on the calculator, your left button and your right button, you can move that spider to the side. So when it says left bound question mark, you're going to move that spider over to the left of the highest point and press enter. Then it will say right bound question mark, and you're going to move that spider over to the right of the maximum point and press enter. And it will put these little triangles up at the top. And that's just giving the calculator a search area. It's telling the calculator to find the highest point between those 2 triangles. And then it says guess question mark, and you can move the little spider near the highest point, or you could just press enter. And when you do that, it will give you the coordinates of the maximum point. So your calculator screen should look like this, and the x coordinates of the maximum point, 2.5, is the time it takes for the height to reach its maximum height, and 15.25 is the maximum height that it reaches. So the question A said the time, we're supposed to find the time when the ball reaches its maximum height, and that would be when t equals 2.5. And this question should be giving us units, so let's just make some up. Let's say time is in seconds and height is in meters, just so we can be using our units. So the time it would take is 2.5 seconds, and the question didn't ask this, but the maximum height would be 15.25 meters. The next thing that you're going to try and find is the time that it takes the ball to hit the ground. And the ball will hit the ground when this graph hits the x-axis. So we're looking for the x-intercept. And we're going to use second trace again. So if you press second, the blue button, and then trace, it gets you back to this calculate screen. And this time we're going to choose 0. So in part A, we used maximum. And in part B, we're going to use 0 in that window. So you're going to press second trace and then number 2 for 0, and you'll have that little spider on your graph again, and you're going to do the same thing you did before. We're trying to find this point right here, so we need to move the spider to the left of it when it says left bound question mark. So for left bound question mark, move to the left, and you should be above the point and to the left, and it puts a little triangle up at the top, and then it will say right bound question mark, move the little spider to the right and press enter, and you'll have another little triangle, and it gives you that search area. And then when it says guess, you can just press enter again, and it will give you that x-intercept. And your calculator screen should look like this. So the after how many seconds will the ball hit the ground? Well, the time is the x-coordinate, so that would be t equals 6.4 seconds approximately. And then for the last part, we're trying to find how high the ball is after 2 seconds. So 2 seconds is about right here. We're just trying to figure out what that height would be. And we're going to do second trace again. And this time you're going to choose the number 1 for value. And when you press value, it should say x equals at the bottom, and you're going to plug in 2. So this allows you to tell the calculator an x value, and then it will give you the y value that goes with it. So type in we'll type in 2, and then press enter, and the calculator should tell you y equals 15. So when x is 2, or t is 2 in this case, y is 15. So how high is the ball after 2 seconds? That would be 15 meters.